A pentagonal lamina having edges 25 mm is placed on one of its corners on VP such that the surface makes an angle of 30 degrees with VP, and perpendicular bisector of the edge passing through the corner on which the lamina rests is inclined at 45 degrees to HP. Draw the top and front views of the lamina. As in the problem specifies one of its corners on VP such that the surface makes an angle of 30 degrees with VP. So the initial position of the lamina should be parallel to VP. That means the surface inclination with respect to VP is 0 degrees. So it is parallel to VP and such that the surface is inclined with respect to VP is 0 degree. So obviously since it is parallel to VP, so in vertical plane we can see the true shape. Therefore, we have to start the problem from the front view, that is in vertical plane. Whether it is resting on VP or on the corner, always the initial position of the pentagonal surface has to be side perpendicular to HP. So here, this is basically because this side opposite to this will always be corner in a pentagon because it is an odd number size. Now, he says, and it is also a perpendicular bisector is given. So we have been drawn a perpendicular bisector, that is A dash, and opposite to the side opposite to this is a corner. So from the corner you draw a midpoint to the opposite to this corner is a side which is C dash D dash, and you mark that point as M dash. So this is the perpendicular bisector. So here this is A dash, B dash, C dash, D dash, E dash, and also we have written M dash. So when you look from the top view, since the surface is parallel to VP and perpendicular to HP, so we can see that in HP you will going to get a line. But since it is parallel to VP, so in vertical plane you will going to get the true shape. That is what we have written. So when you look from the top view, A dash, B dash, C dash is visible, that is near to the observer, so ABC is visible, and D dash and D dash is away from the observer, so it becomes invisible, and E invisible, and of course M is also invisible. So this is in the 2D analysis the same thing which we have written here with the pentagonal plane, pentagonal lamina with one of the sides is perpendicular to VP. Construct this pentagon, and then since it is perpendicular to HP, so in HP you will going to get a line here. So A, B, C, and then D and E is in bracket because when you look from the top view, D dash and D dash is away from the observer, so it becomes invisible, and of course M dash is hidden by the corner point, the point C, so M is in bracket. And then he says the surface is inclined, makes an angle of 30 degree with VP. So in the second position, you can see the surface is inclined at 30 degrees to VP, and that surface inclination can be seen in the horizontal plane. You can see that, and still the surface is perpendicular to HP. So you are getting a line in the top view. And when you look from the front view, you are going to get a projected surface, and that is not shown because due to the clarity. And this is the perpendicular bisector. Once the surface is inclined, you can see that the perpendicular bisector is also inclined. So that is the reason why AM is inclined at 30 degrees to VP. Once the perpendicular bisector is inclined, so what happens? And the perpendicular bisector is inclined. So that perpendicular bisector in the front view will going to become the apparent length. So here you will going to get the apparent length. Next we will go to the next step. Then and the edge passing through the corner with the lamina rest is inclined at 45 degrees to HP. So now here he has given the actual true inclination, but in the second position front view you can see that it is the apparent length. Since there is the problem in the problem it has given it is inclined to HP at 45 degrees, so it is the true inclination. And then in the second position front view, the perpendicular bisector has got apparent length, so we need in the third position to find out the apparent declination. So to do that, so first you draw a 45 degree line and then take the true length of the perpendicular bisector. Since the perpendicular bisector is parallel to VP here, so you are getting the true length here. So you measure the length from A dash to M dash. From A dash you cut an arc on the 45 degree line. So you're going to get the 45-degree line here on this. Then draw a locus. Then take the apparent length of the perpendicular bisector from A dash to M dash in the second position of front view. With same point A dash as center, cut an arc on the locus so that you are going to get this point M dash. Then join A dash M dash with a thin line and extend it on this and mark the angle as alpha. Why? Because that is the apparent declination with respect to HP. Now, on this A dash M dash line, you rewrite the second position front view, and to this you write the top view. So this will going to be the final position of the third position top view, such that the A is still on the vertical plane. So this is how the construction has been done in the 3D also, and when it is projected, you are going to get this point here. So this is the angle at which you are going to be rotated in the front view. And when it is still, you can see that in the top view, A is still on the vertical plane. So this is how we can be analyze this 3D analysis when you are doing on the problem of pentagonal lamina with apparent declination, which is alpha inclination. Now we are going to solve the problem in sketchbook. First, we will going to draw the XY line and mark VP and HP. And since a pentagonal surface of 25 mm side, which is resting on corner on VP, such that the surface makes an angle of 30 degrees with VP, and the perpendicular bisector passing through the corner on which the lamina rests is inclined to HP at 45 degrees. So now, in the first position, whether it is resting on corner or on the side, always the initial position of the side has to be perpendicular to HP. So first you draw a line of 25 mm and mark the point as D dash and C dash in the vertical plane. By using the protractor at the point D dash, measure an angle of 108 degree with respect to C dash D dash and draw an inclined line. Similarly, at C dash, you draw by measuring an angle of 108 degree and then draw an inclined line. Then, by using the compass, by measuring the radius of 25 mm with D dash as center, cut an arc on this to get this point E dash and mark the point as E dash. Similarly, with C dash as center, cut an arc on this inclined line to mark this point as B dash. Then, from this point E dash, you draw an arc, and from B dash, you cut in the previously drawn arc and mark the point as A dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, and D dash to A dash with a dark line. So this will go to complete the construction of the pentagon in the first position in the front view. Now to this we need to write the top view. So draw a vertical projector from A dash to the XY line and also from B dash to E dash to the XY line and C dash D dash to the XY line. And since he says one of the perpendicular bisector, the corner opposite to the side, midpoint of the opposite side, which is C dash D dash, you mark the point as M dash. And also here, since when you look from the top view, ABC is near to the observer, so ABC is visible, and D dash and E dash is away from the observer, so it becomes invisible, which is in bracket. Similarly, M dash is on the line of CDM, so you mark this point as M. And by taking the convenient distance from the first position top view, and you mark the point on XY line, and since it is resting on one of its corners on VP, so mark the point as A. By using the protractor, you measure an angle of 30 degree to the XY line, which is as shown, and then draw an inclined line. Then with A, by using the compass, you measure the distance from A to C, and with A as center, cut an arc on this point, and mark the point as C, bracket D, and bracket M. Similarly, you measure the distance from A to B with A as center, cut an arc on this inclined line to get this point B and A in bracket. Then join A to C with a dark line. So you're going to get the surface inclination with respect to VP in the second position top view. Now, to this you have to write the front view. So draw a horizontal projector from A dash and M dash. Draw a vertical projector from A to intersect at this point A dash, and similarly from here M to intersect at this point, you mark this point as M dash. Draw a horizontal projector from B dash and E dash, and draw a vertical projector from B and E to intersect at this point B dash and this point E dash, and mark the point as B dash and E dash here. Similarly, draw a horizontal projector from D dash and horizontal projector from C dash, and draw a vertical projector from CD to intersect at C dash and D dash, and name the points as C dash and D dash. So once you get all these points, then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, and D dash to A dash with a dark line. So this will going to be the second position front view. Now the perpendicular bisector passing through the edge which is resting on VP is inclined at 45 degrees to HP. So that means he has given the true inclination, but once the surface is inclined to VP, so the perpendicular bisector is also inclined to VP. So obviously you are going to get this perpendicular bisector as apparent length. But the inclination given is a true inclination, so you cannot reproduce the second position front view in the third position on this true inclination line, because this perpendicular bisector is got apparent length. Since this perpendicular bisector has got apparent length, so we need to find out in the third position front view the apparent inclination first. So to do that, consider any point and draw a horizontal line, and then to that point, that is, you mark the point as A dash. With that point, by using the protractor, you measure an angle of 45 degree with respect to HP. So that means this will going to be the line which will be 45 degrees to the XY line. So draw an inclined line. So since it is the true inclination line, you have to take the true length of the perpendicular bisector. So where I am going to get the true length of the perpendicular bisector? The perpendicular bisector here, AM, which is parallel to VP. So I am getting the true length here, A dash M dash. So then by using the compass, you measure the distance from A dash to M dash in the first position front view. So with A dash as center, cut an arc on this 45 degree line. So you are going to get this point here. So through this point, draw a locus, because this is the true length and the true inclination. Then we need to find out the apparent declination. So measure the length from A dash to M dash in the second position front view. So this is the apparent length, because the perpendicular bisector AM is inclined to VP. So obviously this will going to be apparent length. With same A dash center, cut an arc on the locus so that you are going to get this point as M dash, and you mark that point as M dash. Join A dash to M dash here, and then show that it is the apparent declination alpha. Mark that all as alpha. Then you mark this point A dash and M dash now. Now you measure the length from A dash to this point, and from A dash you cut an arc on that apparent inclination line or apparent length line. Since this B dash E dash is perpendicular to A dash M dash, so by using the protractor, keeping the center point as this on the A dash M dash line, draw a perpendicular to this inclined line A dash M dash. So then join and draw a perpendicular line here. Again, with this point as center, take the radius of this point to A dash and this point to B dash. Both will going to have the same length. With this point as center, since B dash is above that inclined line, from here you cut an arc on the above, and also from this point, same point, you cut an arc on this, and mark the points as B dash and E dash. Similarly, draw a perpendicular from this M dash on with respect to A dash M dash. So that means by using the protractor, keeping this as a center, it is aligned with A dash M dash, and measure an angle of 90 degree with respect to A dash M dash, and draw a perpendicular line. Similarly, with M dash as center, take the radius of M dash C dash and M dash D dash. Both will going to have the equal length. So with same center, M dash in the third position front view, cut an arc on the top side and also on the bottom side, and mark the points as C dash and D dash. And now join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, and D dash to A dash with a dark line. So this is how we will be able to produce the third position front view, such that the perpendicular bisector is inclined at an angle of alpha with respect to HP, because we have found out the apparent declination. Now on this, to this we have to need to write the top view. So draw a vertical projector from A dash and draw a horizontal projector from A to intersect at this point A. Similarly, draw a horizontal projector from B dash and E dash and draw a horizontal projector from B and E to intersect at B and E and mark the points here as A, here it is B and here it is E. Then similarly, draw a horizontal projector from C and D and draw a vertical projector from C dash and also from D dash to intersect at C here and mark the point as C and intersect at the point D and mark the point as D. Then join A to B with a dark line, A to B, B to C, C to D, D to E, E to A with a dark line. So this is going to be the final solution for this particular problem. But we have to, whether we are going to check once more whether it is satisfied all the conditions or not. So a pentagonal lamina of 25 mm side is resting on one of its corners on VP such that the surface makes an angle of 30 degrees with VP, and the perpendicular bisector passing through the edge which is resting on VP, which is A dash M dash, is inclined at 45 degrees to HP. So you can see, since he has given the true inclination, so we have taken the true inclination first, but we have the apparent length, so we need to find out the apparent inclination. So we found out that apparent inclination, and still in the final position you can see the edge is resting on the corner is resting on the vertical plane. Since we have satisfied all the conditions, hence the problem is